Today's video will explain how to optimize a many-way decision problem. Hello, I'm James Helfrich. There are four types of decisions we typically encounter in code. There is option, no option, option A versus option B, a small number of options if, else if, or a large number of options, and usually we use a switch case or a match case statement. This video will explain how they're compiled and then how to use them best to optimize our code. There are four basic types of decision considerations. There is one option, there is option A versus option B, there are a few options, and there are many options. We're going to talk about the many options scenario today. Basically, if you have more than 2 or 3 decision options, think about using a switch case statement, not only for readability reasons, but also in many cases, it is the optimal solution. Now, there are 4 ways the compiler or the interpreter can treat this switch case statement: a sequence of if-else statements, iteration, a binary search, or a jump table. Let's take a look at each one of these. The compiler interpreter can convert a switch case statement to a series of if-else statements, where each case label is its own if-else clause. So for an example, if I say switch case 1, case 2, case 3, all the way up to case 16, the compiler could turn this into an if, else if, where if an if statement is true, it's going to jump to a given go-to label. This is O sub n. If there are twice as many case labels, then there's going to be twice as many if statements in my pseudocode. The next one is an iteration. In this case, I'm going to take my switch case statement and turn it into a for loop. We're just going to go through each individual element if the expression equals the key. Now notice, this is also O sub n. If I double the number of case labels, I will also double the number of times I go through the for loop. The next one is a binary search. I'm going to take the switch case statements and I'm going to turn into a bunch of highly nested if statements. The depth of the if statements is going to tell you how many we're going to execute in a given iteration. And since the depth is log n of the number of case labels, this whole thing is O sub log n. Clearly much more efficient than O sub n. And the final is to create a jump table. And this is kind of difficult to explain, but basically every different collection of options, which are part of the case label, will be put into its own part of code. And then as you increment through the indexes, all the different case labels, then we will jump to the given label. This only works, importantly, this only works if the case labels are a sequential collection of numbers. If there's a gap or if they're not sequential, then we cannot use a case label because our jump table will be very large. So let's take a look at some code in C++. Here I have a collection of case labels, 1, 2, 3, 4, 5, 6. Now, because these are in sequence, the compiler can turn these into indices, and it should be easy to create a jump table. So when I compile this and run it, I'm going to break into the debugger, and we're going to see what the output's going to be. Now, when I broke into debugger, I'm going to enter the disassembly view, and I can see the compiled code corresponding to this particular switch case statement. Now, it's difficult to see how this works, but basically I'm going to take the index that comes from my controlling expression, and I'm going to add that to the address of my case label. And with that, I'm going to jump to that location. So if there is 1,000 different case labels, I can still do this in O sub 1 because that jump is just a bunch of addition. It's just like I'm accessing an element from an array. Okay, now I'm going to modify my code so that these case labels are not a sequence in memory, that there's going to be large gaps between them, and therefore it's be impossible for the compiler to turn these into indices. And then when I run this and then break into the debugger and look at the disassembly, we're going to notice no longer that math on the index, but rather we're going to notice a bunch of jump equal marks. And notice when I scroll up, jump equal, jump equal, jump equal, jump equal. In other words, this is a whole bunch of if, else if statements, which is O sub n. And so the big takeaway from this is that whenever you have a bunch of case labels, try very hard to make them 1, 2, 3, 4, 5, a bunch of indices without gaps, so the compiler can turn it into a jump table rather than resorting to an if, else if statement. If there's a large number of elements in your case labels, then this can have a significant performance difference. This is the many options section of the decisions chapter of the software design textbook.